Rate of reaction. Objective: to learn the rate of reaction and the factors affecting it. A chemical reaction is a process during which certain substances, known as reactants, undergo changes to yield new substances, known as products. During a chemical reaction, the bonds between atoms in the molecules must be broken in order for a new molecule to form. The breaking of bonds requires energy. Let's consider the reaction between nitrile chloride and nitric oxide. During this reaction, a collision between the two molecules will break the bond between the nitrogen and the chlorine in the nitrile chloride, resulting in the formation of nitric dioxide. The chlorine, which has broken off, will bond with the reactant nitric oxide to form nitrosyl chloride. For a reaction to occur, the two species must be properly oriented in relation to one another when they collide. The reaction will begin only when the nitrogen atom from the nitric oxide collides with a chlorine atom from the nitrile chloride. Any other collisions, such as one between the oxygen of nitric oxide and chlorine, or one between the nitrogen of nitric oxide and the oxygen of nitrile chloride, will not yield products. Instead, the atoms will simply bounce off one another. The rate of reaction will increase with an increase in the temperature. If the temperature on a system is increased, the particles in the substance will move faster, leading to an increase in collisions. The rate of reactions will also increase with an increase in the concentration of reactants. As their concentration increases, the frequency of collisions between the molecules or atoms will also increase, thereby increasing the speed of the reaction. The reaction between gases will increase with an increase in the pressure, and an increase in the pressure will lead to an increase in the concentration of the reactants. Consequently, the collisions will increase and the reaction will speed up. Summary: in a chemical reaction, substances known as reactants will undergo changes to yield new substances known as products. The rate of reaction will increase with an increase in temperature. The rate of reaction will increase with an increase in concentration. The reactions between gases will increase with an increase in pressure.